Algebra 2, Lesson 19, multiplying polynomials. We're going to get into basically our new information today is going to be foiling, F-O-I-L, first, outer, inner, last, when we talked about multiplying certain polynomials. Is that something that we're familiar with? All right, so it's not necessarily new information. It's just being presented as new today. So to multiply two polynomials, each term of the first polynomial is multiplied by each term of the other polynomial. It is... basically, it's advanced distribution, okay? After each of these products is found, the like terms are combined. To multiply two binomials, a method called FOIL is used. It's often used. The letters F-O-I-L stand for where the terms are found in the binomials. Probably help if I could write or at least type correctly. Let's fix all of that because that's a mess. Okay. All right. So the FOIL method. We should be familiar with this. They're basically just giving you an example where I have x plus 3 times x minus 5. The first terms are x and x, so their product is x squared. And it's difficult with Smart Notebook to do exponents, and whenever you start putting things in a table, it really doesn't like you just putting things in where you would like to put them. So I'm using the caret symbol to represent x squared. Does that make sense to everybody? All right, that's not going to mess you up seeing that in the notes. Okay, good. All right, so x times x is x squared, right? And just because I've dealt with this here recently, and maybe it's from like lower level classes like Algebra 1 or maybe algebra or geometry or something like that, but I've seen students who really struggle understanding the difference between, say, something like x plus x equaling 2x and x times x equaling x squared. Do we understand the difference between those two operations? Yes? Okay. So we need to be able to know the difference when we're going to get a change in coefficient versus a change in exponent. Okay? So x times x is x squared, all right? And I like to, as I do it, draw my arrows, right? Something like that, or connecting those two things, so that I know in the end of it, I should see 4 different lines being drawn, so that everything in the first set of parentheses is multiplying by each separate term in the second set of parentheses. So outer, all right, so we had first, which is we're multiplying the first term in each set of parentheses, so x times x. Outer is my outside terms in each parentheses. So x times negative 5, okay, outer, okay, which is going to be negative 5x. We understand that? Okay. And then my inner, which is I, 3 times x, is going to be 3x, which is going to give me like terms, but we won't go there yet. And then finally, my last terms, all right, which is the last term in each set of parentheses, which in this case is 3 times negative 5, which is negative 15. In expanded form, I'm seeing it drawn out down here, where I have x squared minus 5x plus 3x minus 15, which allows me to combine like terms, negative 5x and 3x. Okay, they're like terms, so all I'm doing is adding or subtracting the coefficients of those. So negative 5 plus 3 is negative 2x. Okay, we're not multiplying anything there. So I wind up with a final on that is x squared, and just so we're seeing it like it would show up, x squared minus 2x minus 15 is my answer when multiplying polynomials. Okay, are we familiar with this? We've done this before. Right, okay. Okay, so this chart gives me some special product patterns. It doesn't mean that you wouldn't still get these things if you FOILed them out. You would still get this scenario. But what this does is it gives me a little bit of a shortcut, so I don't actually have to do all of FOIL. Okay. For instance, this is maybe one that is dealt with about the most, which is sum difference, which is, let's say if I see something like x minus 5, x plus 5. Okay, that's a sum difference because I'm adding and subtracting the same constant in both sets. Okay, and when that happens, what I'm going to wind up with is that the middle two terms, the outer and inner, whenever I get those, they're always the opposite of each other, so they cancel out. So if I see a sum difference, I actually don't have to do the outer and inner. I just do first and last. So I just do x times x, which is x squared, and my last, which is my negative 5, and my positive 5, which is going to be, in this case, negative 25. I don't have to do negative 5x and positive 5x. Does that make sense? Because the negative 5x and the positive 5x are always going to cancel. So do we understand some difference? Okay? All right, so if I see, in fact, later on, when we see something like x squared minus 25, I should know that a sum difference got me there. Okay, because I'll always wind up with something like an x squared minus a perfect square. Okay, so if I see x squared minus a perfect square and I go back to get the terms, it should be a sum difference of the square root of that negative constant. Okay? Maybe that's more information than you need at this moment, but in any case. Then we have a square of a sum, all right, which is where, they're saying here x plus b squared is going to be x plus b a plus b times a plus b. And it always winds up pretty much in the same situation where I've got a squared plus 2ab plus the b squared. So let's go ahead and try to do this. Let's say we had x. Again, we'll stick with our number 5. Okay, we have x plus 5 squared, right? That's equal to x plus 5 times x plus 5. The big mistake that people make whenever they see that is they want to take that and they want to say, well, that's going to be x squared plus 25, because they just square the individual terms. But that's not what we're doing here. We're squaring the whole thing by itself. Okay? I square the individual terms inside the parentheses. So as I look at this, I'm going to get x squared plus 5x plus 5x, right? So I'm getting double that, which is plus 10x plus 25. And you see that there where it's plus 2ab. We're saying we're doubling a times b, which is whatever this is. Let's see if I'm looking at this right. Yeah, I'm basically taking that, I'm getting the sum of it, okay? Which is where we see a square of a sum. Okay, you follow me there? Okay, and again, would I get the same answer if I folded out and combined like terms? Yes, all we're trying to say here is a simple way of looking at that is if I've got a 5 and I see that I'm doing this, it's sum, right, of the same number, right? I'm getting my x squared, right? I'm going to double the 5, and then I'm going to square the 5. I'm going to wind up with plus on both of them. Okay? So if I know that pattern, I don't have to do as much work. I can be a lot quicker at it. So for instance, let's do another one just so that we can see how quickly it can be done. Let's say I have x plus 3 squared. I know that that's going to be x squared plus 6x plus 9. Take that, double it. Okay, 3 times 2 is 6. Then square it. Okay, 3 squared is 9. You see how much quicker that was than foiling? Okay, you get it? All right, do you want to try another one? Okay, let's try one more. Let's say we had x plus 7 squared. What's that going to be? I'm going to get what? X squared plus 14x plus 49. All right, does that make that easier? You multiply it by 2, right? And then you multiply it by itself. Okay? Now we have a square of a difference. All right, so let's take our x minus 5 squared. All right, that's still FOIL. All right? Except in this case, I'm getting x squared, and I'm going to get negative 5x and then negative 5x, right? So, which is going to be not 10x, but no. What's negative 5x and negative 5x? No, you're trying to multiply. We're not, look, you would get x squared minus 5x minus 5x, right? What is that? That's not, you're trying to multiply and wind up with a positive. Negative what? 10x. Okay, we're trying to do something else here. But negative 5 times negative 5 is positive what? 25. So the pattern here is that I'm going to get x squared, and then I'm going to double it, but I'm going to wind up with a negative. But then because I'm multiplying a negative by a negative, I'm going to get the positive square 25. All right, which is why you see it written like that. Okay, let's pick another one and see how much quicker we can be once we understand the pattern. Let's say x minus 6 squared. We know we're going to start off with x squared, and then negative 12x plus 36. Do we get that, or do we want to do another? You got it? Okay. So that's a square of a difference, but it's got to be like this. Or even if they show me, x minus 6 times x minus 6, it's the same thing. Okay? So all that does is allow me to get to the answer quickly more quickly if I understand the pattern. Now, it has to be both. It can't be like x minus 6, x minus 5. Okay? You won't get that pattern like that. Okay? It'll still be negative positive, but it won't be just as simple as doubling and then squaring. Okay? Questions so far? None? All right. So let's look at what we've got here. All right. We've got 6x plus 4y squared. Okay. So you are going to rewrite this, or I would rewrite it as 6x plus 4y times what? 6x plus 4y. And then follow my order, which is FOIL. What's 6x times 6x? 36x squared. Now what? What am I multiplying? Okay. 4y times 4y, which is what? 16y squared. All right. And so that's first. Outer. Now what's next? What's the I? 4 times 6, right? That's my inner. 24 what? xy, right? Because they're not the same variables. All right, and what's my... we did first, didn't we? We did first, okay, 6x times 6x. And then we should have done 6x times 4y, right? All right, what was that? 24 what? 24xy. Okay, so now we need to get our terms together. We got 36x squared plus 48xy plus 16y squared. Okay, now this is also the sum of a square, right? Right, if we go back and we look at that other deal, right, we'd have our 36x squared. Then we would be taking 6 times 4 times 2, right? 6 times 4 is 24. 24 times 2 is 48, right? And then we would be getting our b squared, which is our 4y squared, so that's 16y squared. So we could have probably gotten there a little quicker, but we wanted to try out some FOIL and make sure we knew what we were doing. Okay, what is the term for what we're seeing there? Q plus 9, Q minus 9. Sum difference, okay? In a sum difference, what are the only 2 steps I need to do in terms of FOIL? Do I need to do all 4, F, O, I, and L? First and last, all right? So what's first? Q squared, and what's last? Negative 81, okay? Q times Q, and positive 9 times negative 9, okay? And you'll always end up with a variable squared minus a perfect square. Okay? We got it? Sweet. Okay. Now, one that the book isn't dealing with is like number 3. Number 3, you're going to FOIL. You're going to FOIL the first 2 terms, and then you're going to take that solution, and you're going to multiply it by the third term. Okay? So this is kind of a long process. So I'm going to kind of work through it as we go. So we're going to cut this guy off right there. Okay, we'll come back to him in a second. What's x times x? I'm going to work it out down here. X squared, all right, so we got x times x. Now we got x times 7, 7x, and we got negative 5 times x, negative 5x, and negative 5 times 7, negative 35, negative 35. Let's go ahead and combine some like terms. X squared plus 2x minus 35, right? Okay, so I'm going to erase that because we've combined those like terms. Now I have to take, let me fix this, okay. Right, we're going to take that and we're going to multiply it by x minus 2. And so what I'm doing here is I'm taking each of these terms like that first, okay? We're distributing each term into the others. So x times x squared is x cubed, right? Okay? X times positive 2x is positive 2x squared, right? And x times negative 35 is negative 35x, correct? All right, now we're going to do the same thing with the negative 2. Okay? Negative 2 times x squared is negative 2x. No, because it doesn't have an x. Negative 2x squared. Okay, negative 2 times 2x. No, not quite. Negative 4x. Okay, and negative 2 times negative 35 should be positive what? Positive 70. Now I need to combine like terms across. Well, x cubed doesn't have anything, right? But what about 2x squared? What happens with those? They cancel out. Okay, so I don't have anything there. All right, but I do have a negative 4x, right? All right, but he doesn't have anything that goes, actually, no, he does have something that goes with him, right? Yeah, negative 35x and negative 4x becomes negative what? Negative 39x. All right, so we dealt with this, we dealt with this, we dealt with that, right? So just plus 70. Right, and we want those in order with my exponents with the greatest variables first and on down in order from there, correct? All right, so we should wind up with that answer right there. Number 4 works out the same way. All right, but that does, hopefully that helps us out in terms of how to set it up, how to go through it kind of step by step. Okay, got trouble with that, you can always go back to the video. I think you guys are out of here at what, like 10:36? All right, so let me go ahead and stop there, give you guys some time to work. All right, and if you have some questions, let me know. Do you have a question? Okay. Is it math related or is it something else? Okay, then let me hit stop on this and I'll answer your question.